Okay, so I guess we can start with your questions, and we can maybe end with your questions as well, in case you think of something as we're going through the topic list. But are there any questions anyone has for me right now that I can answer? Yes, it will. Yes. Yeah, I know I've been talking the whole semester, really, about how I wish that we could have the exams on campus. No, we lost somebody. I wish we could have the exams on campus, and it just it didn't seem right to have the first two exams be online and then move the last two exams on campus. Like, it would have still been the same exam material. It just would have been a different process for taking the exam, so it wouldn't have been really different. Excuse me. But it just seemed like like changing things up more than halfway through the semester was not the best idea. No, it'll be the same as the previous ones. It'll be just like the previous ones. So the same rules that we had for 2 and 3, exams 2 and 3, will have the same rules for the final. That was one thing I was actually going to ask you all about, Ellie, the availability, because I don't want to have it available for the entire finals week. But I'm not entirely sure. What I might do is, because there is usually a day. Actually, let me see if we have that. In a normal semester, for a class like this, we would have a time. So let's see, Monday, Wednesday. I guess I can show you all what I'm seeing here. Let me share my screen. So, according to the final exam schedule at TCC, Monday, we're not a Wednesday class, but a Monday at 2:30, the exam should be Monday the 10th, so a week from today, from 2 to 3:50. Although, really, the lab we have is at 2:30. If this had been a normal class, the actual lecture period would have started at 1. So perhaps Wednesday would have been the time that we would have taken it. What I might do is go off of that and say that because if this had been an on-campus class, the lecture would have been at 1, because we would have 80 minutes of lecture and then the lab at 2:30. I might set Wednesday as essentially like the middle point, and like give you a couple days with, or maybe 2 or 3 days with maybe Wednesday as the middle day to take the exam. I don't feel super strongly about that, so if everyone really doesn't like that idea, I'm not completely opposed to changing that. But one thing we cannot do is what we did for the previous 2 exams, where it's available over a weekend and you can do it up till Monday. Like, we can't do that for the final. Because I need to have my grades in Monday, so I can't have students finishing taking the final on Monday, so that's just not possible. So it will have to be sometime during finals week. It can't be the weekend at the end of finals week. That is not a possibility. So for those of you that are here, do you have a strong opinion as to when the exam should be? Like I said, I'm planning on giving you like a 2 to 3 day window, essentially. I'm not going to give you the entire week, but I will give you more than just, a few hours. I know some professors try to do these where you really do just have like 2 hour or 3 hours. You have a 3-hour window and you have to take the exam. And so everyone is on taking the exam at the exact same time. I don't think that's quite reasonable, as this is mostly an online class and you took it at least partially because of the schedule flexibility. It could be from Wednesday to Friday. I wouldn't be terribly opposed to that. Okay. So we have Wednesday to Friday. Friday would also work. Okay. Does anyone have a great objection? Does anyone really want to do it earlier than Wednesday? Doesn't seem like it. Okay, so maybe that's what we'll do then. Maybe we will just do it Wednesday to Friday, so it'll become available Wednesday morning, and you'll have Wednesday, Thursday, and Friday to take the exam. And Friday would be your last opportunity to take the exam. Technically, Friday is actually it's graduation night. Like it's not commencement. Or is it commencement? I always get the names of those things mixed up. But that is when graduation is supposed to happen. It's Friday night. Or did they move that to Saturday? I don't know. It's that weekend. That weekend at some point. I'm pretty sure it's Friday. It's when graduation is. Although because of COVID stuff, they're not having a normal graduation. But it seems like last semester they moved it to Saturday morning instead of having it Friday evening. So I don't know what they're doing this semester. Anyway, not important for us. So we'll do Wednesday through Friday at midnight. So you have up until midnight on Friday to get it done. That should give me enough time. I'll have Saturday and Sunday to compile grades and work out letter grades and stuff. No, not this week. So this is not finals week. So let me show you. Let's see. Well, actually, let's not do it there. Let's just look at it in. Let's look at it here. Where is our schedule? There it is. So if we look at our schedule here, this is the week that we're in right now. So this is our essentially preparing for the finals week. So the final exam is next week. So we have a little over a week for you to prepare for the final. So if it becomes available Wednesday, you have 9 days essentially to get ready for the exam, which should be plenty of time. But again, I realize that a lot of you probably have multiple classes, and so it's not just my class that you're getting ready for. So I'm sure you'll keep busy, and I know a lot of you work as well. So we have this week. This is what we would have called a dead week. When I was at TU, we had dead week every semester, which was, everyone had to have that. This is actually not required at TCC, and I actually normally don't have a dead week. If it was just a normal on-campus class, I would kind of sort of have a dead week where I would try to get stuff done, where we would just review the last week of class, but I didn't always succeed. Sometimes I would get a little bit behind, and we would actually have to cover a little bit of new stuff right at the very end. But a lot of schools, they will have built in a dead week where you don't even have classes scheduled. Like, you're not allowed to have classes scheduled. At TU is a bit different because it wasn't a full week. It would be 3 days usually. So you'd have Monday, Tuesday, and Wednesday with nothing scheduled, and then the finals would start Thursday and go through like the next Thursday. It was weird. Anyway, let's go back over here. So we have this week to prepare, and then the beginning of next week to prepare as well. And then we will have the final on starting Wednesday. And by the way, if you all would like to do what we're doing today again next Monday, that's also a possibility. I'm not against that at all, even though it is technically finals week and like we're not scheduled to have class. I would be fine meeting like this on Collaborate again, because hopefully you'll have some time between now and then to get some studying done, come up with some new questions, come up with some stuff that you're not sure how to do, things like that. Let's see. Hold on just a second. If I'm going to look that up, I need to pause the recording so that the people watching on YouTube later can't see this. Go. So it's 31 questions. 4 to 5 minutes per question is what you'll end up with, which I don't think is unreasonable. Any other just general questions about the exam or other stuff in the class, not necessarily the exam even? No? Okay, well, if you're typing out a question, feel free to finish typing that out and put it in the chat, and I'll get to it in just a second. I think what we can go ahead and do now is look over the final topic list. So let me share my screen again here so you all can see it. And this is available on the Blackboard site as of about 20 minutes ago. And it is in the exam folder. So if you go to the exams folder down at the bottom, you should be able to click on a link and download this. So we don't have that many topics here. There's what, like 12 maybe? 1, 2, 3, 4, 5, 6, 7, 8, 12, 13 different topics here, and some of these are kind of multi-part topics, like the grams to moles, moles to molecules conversion. Like, technically speaking, that's kind of combining a couple different things together. Same type of thing here with wavelength, frequency, energy. Like, there's a couple different things, but they're all very closely related. It's not like I just said all of chapter 9. That's one topic. No, it's nothing like that. I tried to limit it as much as possible to what I thought was the most important. So if we just start up here at the beginning, unit conversions. This is going to be a big one. There are going to be multiple unit conversions on the final. The main reason being is this is one of the most important things for you to be able to do in this class, is to be able to take a value with a certain unit and convert it into a different unit. So it's still the same value, like it's still the same physical value, but you're describing it a different way with a different unit. That's a very, very important skill to have, and so you will 100% be tested over that on the final. And there will be multiple questions where you'll be doing unit conversions. And it'll be, and by the way, all of these topics here, the questions that I ask will be just like the questions that you got in the first 3 exams. So I'm not going to have questions that are totally off the wall and completely different. They actually will come from the same overall pool of questions that I use for the first 3 exams. So because of this, there's not going to be a practice exam for the final, because it's all the same topics and the same formatting and everything from the first 3 exams. So the first 3 exams were essentially a practice exam for the final, all 3 of those. So if you remember, or if you can go back and look at your exam for Unit 1, the style and format of questions where I asked unit conversions, same style and formatting for the final. Same type of thing here with balancing. So there will be at least one question where you will balance a chemical equation. And if I remember correctly, the way that that's written in Blackboard is I give you the equation and then you just fill in the coefficients, essentially. So you would just put in a 1 and a 2 and a 1 and whatever the case may be to get those equations to balance. But that is something you'll need to do. This one is another really important one. You will have at least one, and if I remember correctly, 2 or 3, at least 2 or 3 questions, where you're going to be doing gram to mole conversions, molecules to mole conversions, and possibly even molecules to grams conversions. Like there'll be different combinations of these conversions. So it's closely related to the unit conversions we did up here, just these are specifically going from grams to moles or moles to grams, and then molecules and moles converting in between those, and going all the way from molecules to grams or grams to molecules, like those conversions. That is, again, one of the really important topics that you really need to know how to do in this class. And so there will be at least 2 or 3 questions on the final where I ask you to do that. Okay, protons, neutrons, and electrons. Being able to determine how many of each of those things an atom has. You need to be able to do that. Very similar to what we did in the lecture videos, where I could give you maybe a mass number and the element, and you would have to tell me how many of each of those things are present. There'll be a few of those. Again, probably 2 or 3 of those, just because they're relatively small and short. It shouldn't take too long to answer those. This is our first one here, first topic that has kind of larger questions. So these first 4 here, those are relatively short questions. They're not really multi-step usually, with the possible exception, I guess, maybe of unit conversions if there's multiple units you have to convert. But this one, you will have multiple steps because you'll need to find limiting reagents and percent yields. And like I mentioned earlier, it'll be the same kind of format that we had on the previous exam, which I think that was exam 2, I think, when we did that. I believe that was exam 2. So it'll be the same kind of style and formatting, but I will expect you to be able to find limiting reagents and find percent yields. And those will most likely be separate questions, just like it was in that exam, to where you would have one question where you would be finding a limiting reagent, and then in a separate question you would be finding percent yields. Any questions so far as we're going through here? No questions. Okay. let's keep on keeping on here. So, molarity and dilution. So this is pretty much just, again, the same kind of stuff that we did in the previous exams. So you should be able to figure out the molarity of a solution given information on its volume, given information on the mass of a solute that is in the solution. You should be able to work that out, and you should be able to use the dilution equation to find the new concentration if you dilute a solution, or find the volume of something needed to dilute a certain solution. Again, we did quite a few examples of this, both in the lecture videos, and then we did some problems in the exams themselves and in the homework and stuff like that. So you should have a pretty good idea of what to expect from that. But I do expect you to be able to find molarities as well as do calculations involving dilutions. So nomenclature is the next topic there, and it's pretty straightforward. Just be able to name stuff. And I will caution you, when I ask you to name stuff, since you're doing this at home, if you were doing it on campus, you know, they're sitting in front of me in the classroom, I don't really worry about this, but since you're going to be doing this at home, and I don't really have any way of stopping you from accessing the internet, I'm just going to tell you, do not trust Google. Do not trust Google. If I give you a molecule and ask, you know, what is the correct name for the molecule described by this formula, don't just type that into Google and write down the name that it gives you. Sometimes Google is right. Sometimes Google is wrong. And if you just type in the name that Google gives you and it's not the correct answer, well, that instantaneously tells me that you just typed that into Google. You didn't even attempt to do it yourself, and you will get 0 credit for that question. So don't trust Google. Google is wrong quite often, actually, because usually what Google will give you is the most common name, and we don't use the most common name. We have a very specific set of rules that we use to find the names of molecules. We have the IUPAC set of rules for finding names. So don't trust Google. Use the process that we used in the lecture videos. Don't just type it in and write down the first thing you see, because very often it will give you the wrong answer. You don't have to have the formulas memorized, no. So like like for example the polyatomic ions, like those you don't have to have memorized. You can have access to those. But I'm not going to ask you to name just a polyatomic ion. I would ask you to name a molecule that could contain a polyatomic ion. But you would be, like for example, you could have something like this. So I could ask you to name that K3PO4. And this would have, so you would have a list somewhere of polyatomic ions, and you would see on the list that PO4 3- is phosphate. And so I'm perfectly fine with you like looking this up on a list somewhere. But then you should know that K3PO4 is potassium phosphate. Yes, you will be naming acids as well. So everything we learned how to name in the lecture videos. I would expect you to be able to name. Okay. Electron configurations, again, pretty straightforward. It would be just like it was in exam 3, so we're into the exam 3 material now. If I remember correctly, these 4 were in exam 1. These 3, I think, were in exam 2. And then the rest of these were, well, no, that was in exam 2 as well, I think. Endothermic, exothermic. But then these were from exam 3. So the electron configurations, just like from exam 3, you'd be filling in the number of electrons in different subshells and or orbitals. With the wavelength, frequency, and energy, go ahead and just delete these because they're getting in the way. These you would be using the equations that we learned in that chapter. So you would have, let's see, it was the speed of light is the wavelength times the frequency, and then there was the energy is equal to the Planck's constant times the frequency. So you should be able to use these equations to go back and forth between wavelength and frequency, as well as working out the energy of photons of light, again, just like we did in the previous exams. Lewis structures and formal charges, same type of thing. You should be able to draw Lewis structures. Again, it's always difficult to write questions like that for an online test, just because the main thing I'm trying to see is how you draw it. Like that's what I want to see, but I can't see it in these online exams. So if I remember correctly, the way I wrote those questions was I would ask you like how many lone pairs and how many bonding pairs are on each of the individual atoms in those structures. And that's how I would determine if you drew the correct Lewis structure. Similar type thing with formal charges, just being able to calculate the number of formal charges. So I don't believe I combined these two in any questions, so you shouldn't have a question where you both draw a Lewis structure and then in the Lewis structure that you have yourself drawn, find formal charges. Those should be two separate questions. So any questions with formal charges, I would just give you a Lewis structure, and then, you know, like for example, this is kind of the simplest Lewis structure here. And, you know, so I would give you something like this and be like, what's the formal charge on carbon in this structure? It's 0, by the way. That would be 0. Everything in here is 0. The hydrogens would also be 0. But it would be something like that, where I would give you a structure and say the potassium maybe, or the sulfur in this structure. What's its formal charge? Via CPR, same type of thing here, just like the questions from exam 3. I know this is kind of a common theme here, but I mean I'm just taking questions from the same pools that I used for the first 3 exams, so they will be very, very similar. So the same kind of questions that I asked before from those, working out what the different geometries are, both in terms of electron geometries and molecular geometries. You should be able to do that, as well as determining if a molecule is polar or nonpolar. So kind of like we did with formal charges, I would give you a structure like this, and you would tell me, number 1, does it have polar bonds? And number 2, is the molecule polar? So you'd have to work that out yourself from looking at the Lewis structure. Alright, so then the last topic here is endothermic and exothermic processes. I'm trying to remember how I asked those questions. Hold on, let me go. I think I remember how I asked those questions, but I want to double check. So, alright, so for the, where'd it go? Nope, that's the wrong one. There we go. So for the endothermic, exothermic processes, and actually let me go back to share my screen again with you all. There's kind of two main things that I want you to know for the endothermic, exothermic processes. Number one, I want you to be able to identify endothermic and exothermic processes based on whether they are giving off heat or absorbing heat. So if they would feel hot to you or whether they would feel cold to you. So if something was giving off energy, giving off heat, that would be an exothermic. And if something is absorbing heat, which would feel cold to you because it's sucking heat out of you, that would be endothermic. So I expect you to be able to identify those two. So if I were just to give you, here's a process, it's hot. Is it exothermic or endothermic? You should be able to tell me it is exothermic because it is hot. It is giving off heat. In addition, I expect you to be able to work out the enthalpy change for a process if you're given the chemical reaction that's occurring. So if I were to give you something like this, so we have some methane here that is burning, and I know that is not balanced. Let's see what we need to do to balance that. We need 2 of those, and then 2 of those. Is that balanced? I believe it is. 1C, 4H, 4H, 4 O's, 4 O's. Okay, so that is balanced. Okay, so we have our balanced chemical reaction here, and that is a gas, and we'll say it's all gases here. So if I give you a chemical process like this, I expect you to be able to find delta H for that process. And if you remember, you do that by looking up the numbers in the appendix. So if you remember, delta H is the products minus the reactants. And so I would expect you to look these numbers up at the back of the book and plug those in. Products times their coefficient minus the reactants times their coefficient, and then give me the delta H for that reaction. All right. Questions about all of that? Sorry if you can hear my kids in the background. They're having a hard time. Any questions? No questions. Well, that's impressive. There's not really a review for this one. You might be able to find an old Collaborate video from a previous semester where I essentially just talk through the same stuff that we just talked about now. But I can upload my recording of what we just did to the YouTube site as well, so you could go back and watch it again. Because I am still recording Been recording for, let's see, 34 minutes. So there might be one from a previous semester. I don't remember if I have one from a previous semester or not. But if I do have one from a previous semester, it would just be the same thing as what we just talked through. I don't have one where I go through the slides or anything like that because it's the entire semester. I'm not going to go through the entire semester's worth of slides. It would just be based on that topic list as well. Other questions? Any special cases in electron emission we know about? No. Nope. And that is actually another... It's a good question because it's another spot where I see students, frankly, cheating quite often. Because if you remember, and this is what you're asking about actually, is that, you know, in a lot of electron configurations, especially with transition metals, you will have electron configurations that do not follow the generalized rules that we learned. And I can tell you many times I have put in electron configurations for a transition metal, and I want you to just follow the rules and write out the electron configuration based on the rules that we learned. And instead, students will just Google it and type in what Google says and end up with a 0, even though what they typed in actually was the literally true and correct electron configuration. It's not what I'm asking for. I'm not asking for you to give me the true and correct electron configuration that you would find in nature. I'm asking you to write out the electron configuration based on the rules that we learned in class. So I'm not asking you to give me the exception to the rule. I want you to use the rules that we learned. So again, don't Google it. You will quite possibly, or maybe even likely, get the wrong answer when you do that. So, short answer, no. There'd be no special cases. Just follow the rules. Other questions? Any personal tips on how to study and be successful, or just try and do an overview on the material we already went through, like if we need more clarity? So my personal suggestion would be, I believe you can still go back and look at your previous exams. At the very least, you should be able to see the question. I'm not entirely sure if it shows you the answers to the questions or not, but I believe you can go back and look at the previous exams that you took. If you click on the score on your grade, the page that shows you your grades, I think you can click on the score and it will take you to your exam. I would suggest looking through those again, making sure you know how to answer, you still know how to answer all those questions, specifically the ones that would obviously be in the final, because not everything from the previous exams will show up in the final. But looking over those, I would suggest going back through the lecture slides that cover the topics for the final, and perhaps like going through and not necessarily watching all of them, although that wouldn't hurt for sure, but more specifically finding where I do examples. Go to the beginning of the example, pause it, you work through the example, and then watch me work through the example after it to see if you did it correctly, if you didn't do it correctly, where did you get off track. So I think that would be helpful. So for like things such as the stoichiometry, finding limiting reagents, for example, we did a couple, at least, examples of that in the lecture videos. So you can go back, find those examples. Right at the beginning where I read through it, you can pause it there, work through it yourself, get an answer, see if it matches what I get. So that would be my suggestion for now. You can try that over the next week, and you can come back next Monday, and we can talk about any more stuff that you were struggling with those. Other questions? And obviously, if you don't want to wait until next Monday, you can always just email me questions as well. But I am planning on being here again next Monday, even though it is technically finals week and we're not supposed to have class. Anything else? We're going to determine polarity via electronegativity differences between the atoms, and if so, can we use a chart? Yes. Yes, absolutely. I will be expecting you to determine polarity using electronegativities, and I am expecting you to have access to that chart. So like all the materials that I gave you, or that I was using in the lectures, those are perfectly fine and safe to use. I'm just saying don't Google an answer, because it will not always be number one correct. Sometimes Google is just wrong. And also sometimes Google might give you the technically correct answer, but that's not what I'm looking for. So don't Google stuff. But anything that I give you in the lecture videos, like the electronegativity tables, or anything like that, you're more than welcome to use. And as far as like electronegativity tables, that's fairly safe to just Google and find one of those, because that's pretty standardized. But things like naming stuff, that's not quite as well standardized. There's lots of common names. The most common mistake is that Google will give you the common name for a molecule, and that's not what I want. I don't want a common name. Anything else? Nothing? If nobody has any other questions, I think I'll go ahead and stop the recording just to minimize its size here.